Hi, this is Ben with X0X0 Stereophonic, and today's video I am going to demonstrate how to convert a Sansui 8080 from incandescent to LED. So if you have a receiver that looks like this, we've got some missing lamps, incomplete dial, we can take it and make it look like this. So if that sounds interesting, stick around. This video is specifically for the 8080, but the process is very similar for the 9090 and other X0X0 series units and DB models. So you can use this kind of as a general guide, but know that it is specifically for the 8080. Now, if you want to purchase the exact kit that I used in this video, go to the description. I will have a link posted there. And of course, if you're following along at home, you're doing so at your own risk. I'm going to start the installation of this kit with the top cover, knobs, and faceplate removed. Now, if you're looking for specific instructions on how to complete those steps, it's probably a pretty good indication that this specific modification is outside of your skill set. So if that's the case, I'd encourage you to seek out a professional technician to install this modification for you, or maybe seek out a mentor in your area that has a lot of experience with this type of thing and is willing to, give you some hands-on help to get this done and get it right. Okay, let's take a look at what we need to complete this modification. So first off, of course, we need an LED kit. You're going to need a soldering iron, some solder, a desoldering tool of your choice, be a vacuum solder pump, manual hand pump, desolder wick. We need an assortment of screwdrivers, wire strippers, nice cutters, some pliers. We've got a needle nose and a 45 degree, your sharp razor knife, some assorted heat shrink, small heat gun, lighter will do in a pinch, some small zip ties. Then optionally, it's nice to have a digital multimeter around for checking voltages, some alcohol and cotton swabs, and finally, if you want to fine-tune the brightness of the dial pointer, having a 1/2 watt resistor kit is nice for dialing that in. So it's quite a bit of stuff. This isn't really a beginner modification. You need quite a bit of things to get going, but most electronic hobbyists should have this type of stuff laying around. All right, let's get going. On this model, I like to start with the more difficult section first. That's these 2 meters on the bottom. So this entire tuner assembly that carries most of the lamps that we're working on can get removed, and then we can get access to the bottom. So that's fairly straightforward. There's a bunch of connectors down here, a single solder joint, and then 8 screws on this chassis. So we'll start out with the screws. We need to desolder one white wire here. Let's get these out of the way first. So this is on the far right of the front end pack. We've got a couple wires here on the AM/FM tuner. This guy, it's important to take a picture of these wires before you disconnect them so that you know which way they go back in. I'm just going to heat up this solder joint on the one white wire on this PCB. That's done. And then these 4-pin connectors, again, a picture is good here. Some of these are keyed, some of them are not. So I've got those 4 connectors removed. And then this assembly will lift off from the chassis. There's one more connector here. Just gets pulled, and that's it. With the tuner assembly removed from the chassis, we've got space to come in here and work on the lamps in these meters. And the unit can be powered on in this orientation without that tuner chassis connected. So this is great for testing. In this unit, all of the original incandescents are working. They may have been replaced at some point in the past, but we're going to convert these to LED for longevity. Looking at the meters here, there is a lamp here and here inside of a cylindrical filter. So we can see the meter kind of glows from the edges. So with the LED conversion, we're going to try to duplicate that as closely as possible. There are a couple different ways to tackle this lamp replacement here. It's a challenge because there's some wires going across the two, so you can't independently pull them out with desoldering some stuff. So we'll start off first by pulling the screws here and pulling this assembly, and then figure out which way is best to access these lamps. We've got 2 screws here on this plate that I want to remove. And this plate basically just acts to sandwich the meters in between the plate and the chassis. So when we pull out here, you can see that we do have a little bit of access to get in here and work on the boards, but we are limited by that, that center bar there. There's a small piece of adhesive on the front side of the meter back behind this edge, and we can gently pry that out. See that adhesive there? And then that gives us the ability to get the meter back through here. I'm going to do that with the other ones so that we can get them both behind this plate so we can manipulate the wiring. So with this plate removed, I was able to pull both of the meters back through the plate here, and now we have plenty of room on this wire to get back behind and manipulate the connections here. Okay, so I have a piece of paper installed across the front of both of the meters to protect them while I'm manipulating them around in the chassis. If we turn the unit on, this is with the original incandescent lamps, there's a voltage across the black and the white wire here. It comes through a little dropping resistor, and then right here I'm going to measure across the actual lamp itself. I can get my probe in here. There we go, so just under 6 volts AC. Now, LEDs are DC devices. If you feed an AC signal into an LED, it's only going to activate on the positive going portion of that waveform. So I'm going to demonstrate that here with a signal generator. What we can get is some flicker. So it's important understanding how this works for this specific installation to minimize flicker. The LEDs that I was provided for the meter and the dial pointer are marked polarized. This means that we have to be aware of the orientation when they're installed so that they operate properly. In our case, it would work either way because this is an AC signal, but there's a way that we can optimize this to reduce the amount of flicker that's perceived. On my Fluke meter, if I test in diode mode, this doesn't work with all meters, but on the Fluke 87.5 it does. If I connect this in the proper orientation in diode check mode, I will get the LED to light. Now if I reverse the leads to put it in the incorrect orientation, it will not light. This is why you generally observe flicker when LEDs are connected directly to an AC source. So we're going to show you that next. I've adjusted the camera to 24 frames per second so that we can more easily capture the flicker on this LED. So on the blue wire and the green wire, I have an AC waveform generated from my signal generator, and then with the black and red I'm just measuring the AC voltage here. So I'm going to run a 60 Hz sine wave at about 5.5 volts RMS to simulate the AC voltage within the unit. So if you're looking at the LED element itself, there's not much of a noticeable flicker, but if you look at the reflection here, you can definitely see that this light is flickering at 60 Hz. Now I'm going to slowly take down the volume, or sorry, not the volume, the frequency of the signal here. Right now I'm at about 6 Hz, so this LED is flashing at 6 times per second. Let's take it down to 1 Hz. So every time that this LED receives the positive going portion of that sine wave, it lights off and then extinguishes. Now, one of the ways that we can optimize this in this specific configuration, because there's 2 LEDs per meter, is we can run them in reverse polarity, and I'll demonstrate that here next. Okay, if we look at the connections here, I have the LEDs connected in parallel, but in reverse polarity. So if I bring these together, and I start this waveform at 1 Hz, we can see that one LED operates on one swing, or the positive swing of the sine wave, and the other on the negative swing. So as I increase the frequency, I'm going to take this all the way up to 60 Hertz. So if you look at the LEDs themselves, they both look like they are on, but you can see this reflection here against the metal. There's much less flicker. Now, this is only because I'm shooting at 24 frames per second, and the camera is capturing frames where these LEDs are off. So what we're doing here is just trying to minimize the amount of flicker so that the human eye has a harder time picking it up. Okay, so I'm working on removing the original incandescent lamps here. I'm just using a vacuum solder pump. You can use a solder wick, a hand pump, whatever works for you and whatever you have. All right, I got this desoldered. All right. So the original incandescent is inside of this little boot, and the goal is going to be getting the replacement inside of this boot as well. This is the original boot that the incandescent lamp was housed in. Now, the new LED with all the heat shrink and stuff, it's going to be too thick to fit through the back of this boot. So I have two options. I can either cut kind of the back out of this so that this does fit through, or I can just insert this directly into the hole here. And I think this is what I've done in the past. And as long as there is enough tension on the wires, you can adjust the angle on this. And once it's in the chassis, it should stay. So that's what I'm going to opt for. So next up, we'll simulate one of these LEDs on and see how well it matches up to the incandescent. Okay, in this shot, I'm going to do a comparison between the incandescent and LED. So on this meter, it's still in the stock configuration. On this one, I removed both incandescent lamps and I have a single LED running. So first, let's power it on. So this is the original look. And then this is with LED. Just a single one. So we can see the lighting is actually pretty good, but the color temperature is way off. If we pull the LED out and look at it by itself, this is actually a very nice warm white. The problem is there's a filter inside of this that's green. So I'm going to open up the back of this meter, pull the green filter, and we'll redo this test without the filter in place. So what we're looking right here is inside of this hole. You can see there's like a little green cylinder in there. So that's what's causing that color discrepancy. So I need to use a razor blade to cut the tape here so that I can open up the meter and remove that filter. With this part of the meter removed, you can now get a clear look at what's causing our issue here, and it's this filter. So this is kind of blasphemy, but in this case, if I want these LEDs to match, I have to remove these filters. So I'm just gonna try to gently do this so that I can preserve these. Sometimes these crack and break, and we just want to be very careful with the meter movement as well. Okay, so I'm just doing this with a little 45-degree pliers, and I was just giving a light grip, just enough to break that adhesive. Come on. There we go. So I'm going to reassemble this and we'll do an A/B comparison in this mode. Okay, again, this is going to be original incandescent on the left. And now LED with the filter out. You can see we've got a much better color match than with that filter in place. It's still not perfect, but once we get that second LED in there and manipulate the angle a little bit, we should be able to get a very good looking meter. Okay, I've got the first two LEDs installed. I just did these by shortening this, stripping the wires, and inserting them from this side of the board and just soldering on the back side here. I'll demonstrate that in real time on the other one. And if you were to follow the traces on here, you'd see that the red wire and the blue wire are connected here, and the red on this side and the blue on this side are connected to give us that opposite polarity. So I'm going to load these into the front, and we'll do an A/B comparison with everything wired in circuit. Okay, let's do an A/B between incandescent on the left and LED on the right. You can see now that we're running off of the same supply, and I have two LEDs in this side that they look very similar. I do have a hotspot on this side, which I will be able to adjust by manipulating the depth and the angle of this LED. So I'm going to wait until I get all four installed and the plate mounted back on here, and then I'll play around with these a little bit, get them positioned, and then zip tie them in their final positions. But overall, even though the color is slightly different, it's much improved with those filters removed, and with LED in the rest of the unit, this ends up looking really good. Okay, the last step here is going to be installing the LEDs on the other side. So since I didn't show this on the last one, I'll show it here. So I've got the original incandescents removed, and now I want to install the LEDs. So to get a length, I'm just going to dry fit this in here, and then I want to give myself a healthy loop to work with. Right about there is going to be good. So I'm going to trim both of these to this length. Okay, so now I have these trimmed down. And then I just need to strip off enough of these to work with. So I'm going to start with that. Just enough strip back that I can insert in the hole. And the originals were installed from the back side, and that's kind of difficult. So what I'm going to do is just shove these in the hole from this side. I just got to make sure these are twisted enough that they don't fray on me. So what I'm concerned about right now is just getting one of these two in. So I'm just going to insert it part way, and it's sitting there nicely. Then just come back, and I'm just going to tack it on from this side. Okay, the red one goes into the hole next to it, and I did need to desolder this little black wire here. So the red one's going to go in, and then the black one is going to be soldered beside it or on top of it. So this is a little bit tricky to get in here. Okay, I've got that one inside of the hole. I'm going to get this. I've got that one in the hole there. I'm just going to get that connection tinned up a little bit. And then I just have to get this black wire placed back onto that pad. Okay, so I've got the blue wire there, red wire there, and the black one's resoldered to it. And then if we trace the pads back, this blue one also connects up here, so we're going to go red in that hole on the next one. Let's see, it might be easier to do this blue one down here first. Okay, so we've got blue and red. Opposite, just like that. And then the last thing is, where I put the new tape on here, I need to just stick a razor blade through that hole quick. All right. And then if I spin this around and just push it through that puncture, it should stay in there just like that. So I'm going to get this other one into position, and then I will mount these with the plate, and we'll clean up all the connections on the back and take care of any hot spots. Okay, this is a shot with LEDs installed in both meters, so without that incandescent reference, I don't think you'd be able to tell a big difference. These are looking really nice. And then if there's an issue with hot spots, like on this side down here, just slightly adjusting the angle, I can get these to even out. So I'm going to end up putting some zip ties in here to get these kind of stationary in this position, and then we'll be all set with the hardest part of the LED replacement on this receiver. The final touch here was just putting a couple of zip ties on the wires holding the LEDs. This gives them a rigid point so that I could manipulate the angle and get the meters to look just how I wanted. So that is in, and that's all set. Next we'll move on to reinstalling the tuner chassis, doing all the indicators and dial lamps. When I first powered this unit up, almost none of the lamps worked. I had the power meters, the phono, and the aux, and that was it. Everything else was dead. So based on the lamps that were out, and because it received FM stereo, but the FM stereo indicator didn't turn on, I figured the previous owner just listened to a lot of radio on this thing, and eventually the lamps burnt out. But after I pulled out the lamps from the tuning and signal strength meter, I tested them. It's just a 9-volt battery, and the lamps are fine. So I tested that circuit with my meter, and sure enough, the voltage was missing. So on these, a common issue that can happen, I guess, is the switch mechanism that lets the lights only turn on for AM and FM. Something goes wrong with that. And I ended up doing a very simple circuit modification on this so that the dial lamps will come on again, and they will stay on in any source. So by default, the 8080 and the 9090 only light the front panel when you're on AM and FM, but it's kind of annoying if you listen to a lot of phono or aux that your dial's not on. So this is kind of like a double whammy fix, which I will show you next. By default on the 8080, the front panel lamps only come on when you're listening to an AM or an FM tuner source. These things are really beautiful to look at. It's nice to have the meters on all the time. And in addition, sometimes the switch mechanism that controls that fails, and then you lose your lamps altogether. That's the case that I have here. So I've got nothing to lose on my unit. The way that we perform this is the second connector over from the PCB that's sitting on top of the switch here. So they're kind of lined up like this in the chassis. So on the second one that has the orange, gray, black, red, I need to disconnect this red one, which feeds the lamp circuit, by just pushing a screwdriver, a flathead screwdriver, into that slot to release the pin, and then we hop it over to this connector on the plug, which has a constant 6.5 volt AC supply. So when we plug this back in, we should get front panel dial lamps on all sources. So now that I've got that circuit modification completed, let's power it up, and I should get at least some of the lamps here. Okay, so my signal strength and my tuning are there. Some of the dial is not there. I'm missing lighting at the front and rear. Our dial indicator is good. And our source selection is there, but they're very dim. I don't know if it's even going to pick it up on the camera. So now I've got FM, AM. Oh, that's Dolby FM on the right, AM, and aux. So now basically everything is working. So there must have been an issue with that contact. Now, I'm going to be converting all this to LED, and one of the things that we'll notice is the dial is going to look a lot nicer. It really pops with LED. This is kind of like a watered-down green color. It'll be much more blue and engaging once we do the LED. I've now got the tuner chassis back onto the unit. All the connections have been redone, and now I'm going to focus on the dial lamps and the indicators. So I'm going to take care of the meters first. On this model, we just have to remove 4 screws here on these plastic shields. On the DB series, this is much more difficult to get to. All right, with those screws removed, I can get these little shields out of here. at least enough that I can reach in here for these lamps. So I'm just going to use a flathead screwdriver and just give a little bit of a push in the downward direction. That's going to let out the lamp. Same thing on this one. Let's try from this side. Just going to hop in here with a needle nose. This is one of the new LEDs that's going to be put in here. You see how that says AC 8 volts? This is an LED that can run in either direction. So if I apply a DC source, if it was just working like a regular LED, it would only light in one direction. So if I spin this around, so this is going to operate again around 120 hertz, not at 60 hertz on this AC supply, so a lot less flicker from an LED design like this. So I'm going to load this one into the left meter here, and we'll see if we can see a difference between the LED and the incandescent. Okay, I have LED on the left and incandescent on the right. Let's power it up. Now on the camera it's a little bit hard to see. I'm going to take some stills as well so that we can see the contrast here, but this is more of a cyan, and this is more of a aqua green. So there's definitely a difference between the warm white LED and the stock incandescent. It's much more of a pronounced difference than we saw with the power meters. But in my opinion, this cyan blue really complements this receiver a lot better than the original aqua green. There's certain vintage receivers that I will just refuse to do LED. I don't do LED on a Marantz 2270, for example. Those ones, if you put fresh vellum paper in them and do original incandescents, that nothing beats it. So I do it kind of case by case. But for this 8080, 9090 series, I really do like the LEDs in these. Now, on the camera, it's picking up kind of a hot spot here, and it looks a little bit unattractive. In person, it's almost like a nice gradient swell from the center, so it looks really nice. Hopefully that'll get picked up in the still. What else? So I have the LED elements facing right out to the meter, basically looking at us in the eye. If I change the orientation, say I go down with it and I point it down towards the chassis, we'll get a different pattern. So you can experiment with the angle there to get a different look in the meter. So I may decide on one way or the other eventually, but facing straight out seems to be fine on these. So next up, I'll swap this one in, and then we will take care of the dial. Remember how I mentioned earlier that before I converted the connector on the equalizer board that I had no FM stereo indicator? That indicator is back now, and also I am getting all of my sources, but I've got something weird going on. So if I pull this FM stereo lamp, you can see how bright it is. There's some intermittency probably within the lamp itself or the wires, but overall that's a nice brightly lit lamp, and it's completely readable on the front panel. Right now I'm activated on Dolby FM, and look at this light. It's barely lit. So there might be a dropping resistor or something that's in line with all of the source indicators that has drifted or something. So I'm going to look at that before I convert this to LED. Okay, I've got the issue here sorted. It ended up being a very dirty control section on this switch. So one of the wafers that controls these dial lamps just was not passing AC. It was basically acting as a resistor. So after a thorough cleaning, these are now operational again. And now we can proceed with the LED conversion. So that'll be next. I'll be dealing with all of the lamps in this area. Next up, I'm going to do the dial lights that are behind this white plastic shroud. There's just two screws that hold it in here and here. You have to be really careful when putting these back in that you don't over tighten, because it will snap the brittle plastic and make it hard to tighten down in the correct position. So I've just got two screws to remove here. And then this section should just pop back. There we go, it's holding me up. I'll remove these two guys again. There we go. Okay. So I just need to pop these and replace them with LED, and then the rest of the work we can do right on the PCB that's on the back side of this. Okay, so I've got all these LEDs loaded in, and I'm just going to start them facing forward. I think in the past I found that angling the outsides just slightly out towards the outsides gives you a better dial fill. We're going to start with this and see how this goes. All right, let's see what the dial looks like with the LED. Oh, that's nice. The dial is very evenly lit. I don't have any dark sections, so having the elements facing straight forward is also good in this, this part of the circuit. Everything matches, looking really nice. So all that's left is the dial indicator and all the source indicators. These are the LEDs that I was provided for the source indicators. Let's take a closer look at the inside of one of these. So if I take away that first layer of heat shrink, what we can see here is there's a dropping resistor on the right, but if we look inside of the LED itself, we can see that there are two elements in there. So this is again a bipolar LED that can run in either direction. And I'm just going to run a very slow AC waveform on this. When we're looking at it from the top, you can kind of see those two yellowish sections. Let's see if I can get it face on. So this is going to be kind of hard to see, but when I feed the sine wave into this at a very slow frequency, we'll see one side come up and then the other. So one of these is working on the positive swing and one on the negative swing. So now we're on this side, extinguishes, and then it'll go to this side. Back to here. Let me switch this to 60 Hertz. And there we are. So we observe very little flicker on this specific LED. So that will be all of the sources on it. The indicator for the dial is going to be the same type of LED that was used in the power meters. And the reason is it has to be very small in order to fit inside of the dial. So the dial will be a regular LED, but all of the indicators will be these dual LEDs. I have the lamp assembly here pulled out and rotated 90 degrees so that we can get a really clear look at the bottom here. This makes it very easy to work on. So with the indicator LED here, eventually these are going to go inside of all of the appropriate holes, but we can see the connection here is kind of loose. We don't want that floating around in there. So what I'm going to do is just add a very thin layer of heat shrink on this to make that connection snug. Okay, I've located a piece of heat shrink with the right diameter to go around this assembly. Now all I'm doing is trying to increase the base of the LED here, the diameter, so that I have a snugger fit inside of the plastic here. So pardon the noise here, we're going to go with the heat gun. Okay, so we've successfully increased the diameter here, and what I'm looking for is a little bit of resistance here when we go into this hole. That's perfect. I have to push it a little bit to get it to go down inside of the hole. So this will allow us to adjust the depth and therefore adjust the brightness and kind of tune it to exactly where we want. If we just left this flopping around in there, we might get a little hot spot and the lights won't be the same brightness as one another. So I'm going to go ahead and put heat shrink on all the rest of these, and then we'll get these installed. Okay, I'm going to start with these two so that I don't lose track of which pads I need to solder to. And I don't need the whole length of wire that's on this, so I'm going to trim these down and strip them, and we'll get them ready to place into position there. Okay, to prep these, I've trimmed them down a little bit, and then I stripped down the leads and tinned them, meaning just putting a little bit of solder on the leads, and then I trimmed them down so they're nice and short, easy to work with. So that little bit of prep work is going to make these much easier to solder on. So I'm going to start with this one right here. And because there's no holes here, I'm just going to put a little bit of solder on each pad. And then as we saw, there's no polarity on this, so this can go in either way. There's no need for this lamp to be in there anymore. Get that out. And one of the reasons the stereo indicator, which is the lamp we're replacing now, the reason that this was working and all the other ones were dim is because this runs on a DC voltage provided by the tuner circuit, where the other ones rely on AC voltage going through the selector switch. So that is the installation of the new LED there. And I can just loop it in and put it in its slot, and then we will set the depth once we get this reassembled. There's not anything back here depth-wise to prevent you from doing a long loop on this, so it's okay to leave a little bit extra there. Then I'm just going to hit this joint with a little bit of isopropyl alcohol just to clean up the flux from the solder. Alright, so I just need to reproduce that process for the rest of the lamps, and then we'll finish off with the dial indicator. Alright, this is what the board looks like with all of the LEDs installed. The final part of this process is replacing this dial indicator, and this is one of the more challenging parts because this is glued in, it's very small, there's glue here, and also you can see there's a dropping resistor in this little window here in the PCB. We're going to need to adjust that to fine-tune the balance on this, otherwise it might be too bright. I know that from experience working on the 9090dB. So I'm going to set this connection up with some clip leads so that we can drop in some different resistor values and see what this dial indicator looks like. I'm going to start by desoldering these two leads here. We're going to hang on to this tube and try to reuse this. There's a little bit of a glue joint up here, so just break that glue, set that aside for later. Now the tough part is getting it out of here. This is a working lamp, but unfortunately I'm going to have to wreck this to get this through, so I'm just going to get my cutters underneath here, and I'm just going to snip this so we can get it out this side, and we're going to end up just pulling this out from the back. So we'll use this too to make sure we have the correct length. And then on this side, there's two little metal tabs here that with the sharp cutters you can just pry. At that point we can sneak this under here. Be very careful not to clip this dial string on accident or get your soldering iron close to it. Maybe a good idea to put a piece of tin foil on this when you're working on this section. It's like catastrophic if you wreck your dial cord. It takes a long time to restring those. Alright, so now this part we're going to have to crack out of here one way or the other. Hopefully the glue... Ooh, that was easy. They're usually not that easy. So this is the dial indicator. Sorry, it's having trouble focusing on this thing. So the new one is the same type of LED that was in the power meters that we did. Now I've already taken the heat shrink off of this. This just barely fits down in there, but we're going to need to make a 90 right away. Yes, so I'm going to put this in here. I'm going to put another piece of heat shrink down and shrink it on at the proper depth. I think the original heat shrink went over the LED itself, and it would not slide into this area. So I'll put a piece of heat shrink on this just up to this point. We're going to bend this 90 degrees, and we should be able to feed that through like the old one. So I'm just going to put it right up to the base of that LED element. Heat shrink this on. There's my vet pliers. There we go. So I'm just going to grab this with my pliers right behind the LED element itself and rotate this down 90 degrees. So we end up with looking like that. Now I don't know if I'm going to be able to get it underneath here again, but I can get it locked into this, and this should be enough for us. Alright, so I've got it underneath the dial string there. fed into position. I'm going to rebend these metal tabs back down on top of the heat shrink. Should be a nice strain relief there. And now we need to make sure that this thing has free movement for the entire range. So if we were to simulate with the old one, the old wire, okay, so our new wire is just about an inch longer. I'm going to leave that excess there. If it becomes a problem, I'll trim it. And before I forget, I'm just going to put this little piece of plastic back on top of these two wires. This helps the lamp glide across when the tuner is being adjusted. Okay, we're going to tip this back down. Actually, you know what? First, I do need to put those temporary leads in. So I'm going to desolder this resistor and get a lead tied into these 2 points so that we can dial in the resistor value for this circuit. Before I tip this board back into the chassis, I just wanted to show what I'm doing in case somebody wants to apply this method to a different unit. So basically, I've removed the current limiting resistor that was in there, a dropping resistor for the original incandescent, and I've tapped in with a blue and a green clip lead here. The blue one I've got connected right to the LED here, and then the green one comes down to the original resistor. This measured about 18K. We're going to start with that and see what this looks like. I'll probably replace this with a different value. And then the yellow wire goes back up to feed the other side of this lamp. So basically, we just relocated that resistor out of circuit to make it easy to swap it out so we can change the brightness of this LED. Alright, so we can see our indicators are functional. And the dial pointer here is what we're focusing on now. So again, I've got this little resistor in here. If I cut this circuit, it's going to kill that lamp. Now, this is looking much better with the stock resistor than the 9090 dB did. What I'm trying to do is get some definition in these little articulated lines here, and also make it so that we're not drastically backlighting or reflecting off the face and lighting up the sources behind this on the dial. So I'm going to check my notes and see which resistor value I used on the 9090 dB. We'll try that first and then go up and down depending on if it's too bright or too dim. Okay, so it looks like the value that I used when I did my 9090 dB was 1.2K. So I'm going to throw a 1.2K resistor in. And what I really need to get is a decade box for doing this. I could do this in seconds with a decade box, but I just haven't had the time to find a decent one and purchase it. So what I'm going to do here is just swap this 1.2K in, and we'll see the difference. Try to get these under the same clip here so that we can fast swap them. Is that going to work? There we go. Alright, so that's the original value and 1.2K. That's looking a little bit too dim for me. It's kind of a little bit washed out. No, I don't know. That might be good. Let's see if we change the depth here. What I'm looking for is a balance, right? I want to make it so that these indicator lights and the dial and everything agree. This is looking too dim with the 1.2K to my eye. Let's try it with the original again. I think that's actually looking pretty good with that original value right there. So we might not need to do any compensation on this model. I'm going to replace this resistor because it's drifted a little bit. I measured it at 18 ohm. So let me see what I've got in a close value. I'll probably do a 22 ohm resistor in there. Alright, this is with a 22 ohm resistor. That's going to be not far off from the original. It's just that was a fusible style. I wanted to get it out of there because that'll continue to drift if it heats up. That's looking pretty good, and I think that'll all balance out once the front panel goes on. So here's a final look at this assembly before I put everything back together. So what I've done is this comes through the little tube, and then I twisted these together just to keep them a little bit tighter. And then to each one of their points, there's my new 22 ohm dropping resistor.
And that's about it. So when I flip this back in, I forgot to mention when I took this apart, to get it flipped up like that, I had to remove these wires from a clip down here. So just get this into position, put these wires back into the clip. Okay, and then just line up the two holes here. That's here and here. Push this assembly all the way to the face, and then again, be careful when tightening down these screws that we don't go too tight and break the plastic. Now, this one's in pretty good shape. The ones of these that have seen more hours will be discolored, they'll be yellowing, and that indicates that the lamps were ran for a very long time. They ran hot and started to make the plastic more brittle. I just check to make sure this doesn't slide. This one's a little bit loose. A little bit more. Not sure if I want to go tighter than that. That looks good. Okay, so while we're in here, we should check and make sure. This is going to need to get angled down a little bit. We want to make sure that throughout the whole range of the dial, that our dial indicator doesn't get stuck on anything. So there's going to be a wood cover on top of this. So we want to make sure this is angled down so it's not scraping on the cover all the time. And that is looking really good. Let's see, I think there was some sort of plastic tie that went around this location. Let's see if that might work. I think it's fine to stay without, but if you wanted to copy the original, I think it does have a tie there. I think I'm just going to leave it. Now, see what's happening here is this is floating on the bottom against this capacitors, and there's a chance that this will get stuck down there between a couple components and limit its range. So I am going to add just one zip tie up here to keep the blue and red wires off of that tuner PCB. So last look at the front dial. I've gone and kind of adjusted the depth on all of these indicators so they don't have any hot spots. And then on the FM stereo indicator, I was having trouble getting it lit all the way to the O. So what I did is I just grabbed a cotton swab and kind of pulled some of the fibers off the end of it, and then shoved that in the hole first, and that acted to diffuse the light, and I got it to where it's, sitting in there well, and the whole word is lit. So I'm really happy with how this one turned out. This is a great LED kit. I'm going to set this up in the photo area so we can get a nice clean look at it with all the covers and everything on, and see how it turned out. Okay, here's a final look at the completed LED modification in the 8080. I'm really happy with how this one turned out. If you enjoyed this content, I really encourage you to subscribe to the channel. I love working on this vintage gear, and there will be many more videos to come. And if you do want to perform this modification yourself and want to use the exact kit that was demonstrated in this video, please see the description below. Thanks again for stopping by.